All right, in this video I'm going to run through some of the right triangle trig word problems. This is the second sheet that I posted on Canvas. So this will be a good opportunity for you could try the worksheet if you haven't already, and then check your answers when you get done, by watching me work through it. So this is a flagpole cast 42-foot shadow. So first thing I do is draw a little picture. It doesn't have to be fancy, but there's a flagpole, 42-foot shadow, so that means the shadow goes out here. That's 42 feet. The angle elevation of the sun is 57. So if the angle elevation means we're looking from here up to the sun, that is 57.4 degrees. And they want to know what the height of the flagpole is. So what we're trying to find out is this. So when you're doing these right triangle word problems, you want to ask, we're going to use the fact that tangent is opposite over adjacent, sine is opposite over hypotenuse, and cosine is adjacent over hypotenuse. And so you look at that and say, what sides do I know and what sides do I want to know? So in reference to 57.4 degrees, I know the adjacent side, and I want to know the opposite side. So opposite and adjacent are the two I want to relate, so that tells me I want to use tangent. So I'm going to write an equation using tangent. Tangent of 57.4 degrees is equal to opposite, which is x, over 42, which is y. So to solve this, I just multiply 42 times tangent of 57.4 degrees, and that will give me my answer. Since 57.4 degrees is not a friendly angle, we'll just go to our calculator and type in 42 times tangent of 57.4 degrees, and I get 65.7 feet. That's how tall the tree is, or the flagpole, I mean. You would want to make sure that your calculator is in degree mode, of course, because you're talking to it in degrees. Okay, let's go to the next one. A 37-foot tree casts a shadow. Okay, so this time we have a tree. Nice tree. 27-foot shadow, so it's the same, almost the same exact problem, just different numbers and context. What is the angle of elevation? Oh, no, this time they're asking for the angle of elevation to the sun, because this is a 37-foot tree. So once again, you know the opposite and adjacent, so we're definitely going to deal with tangent. But this time we don't know the angle. So we put a little theta there, and we go, opposite is 37, adjacent is 27. And now to solve for theta, we have to undo tangent, which means there's a little button on your calculator that has like a tan with a -1 raised up there. So it looks like this. So you're going to take basically inverse tangent undoes tangent. So on this side it's going to be tangent to the -1 power of 37 over 27. So you're going to go second tangent, 37 divided by 27. And theta I get is 53.9 degrees. And we know it's degrees because my calculator is in degree mode. Okay. Moving right along, an airplane is flying 4,000 feet above ground. So here's my cute little airplane. It's the cockpit. 4,000 feet. If the angle of depression from the airplane to the beginning of the runway, so if I'm looking down from here to the runway, it says the angle of depression is between the line of sight and a horizontal line. We know that this is 5.4 degrees. Because of geometry, we know this is also 5.4 degrees. Okay, what is the horizontal distance to the nearest 1/10 of a mile of the airplane to the beginning of the runway? Airplane is flying. Yeah, okay, so I think I maybe am a little bit ambiguous about this because it says, it says horizontal. Good, I'm glad I said that. What is the horizontal distance to the nearest 10th? So we're looking for this down here. Once again, this is going to be tangent. Man, are they always tangent? No, they're not always tangent, but so far they have been. So this would be tangent. Why is it tangent? Because we know the opposite side. Whoops, sorry. We know the opposite side, and we want to know the adjacent side. So tangent of 5.4 degrees is going to be equal to opposite over, I don't know. So to solve that, I'd multiply both sides by x. X times tan of 5.4 degrees equals 4,000. Then divide by tangent. So that'd be x equals 4,000 divided by tan of 5.4. So put that in my calculator, 4,000 divided by tang of 5.4. And I get x is equal to 42,315.6 feet. Notice it's quite a bit bigger than the 4,000, but that's comforting because this angle is so small, so we'd expect this this side to be a lot larger. Because if that's 5.4 and this is 90, we know that's like 85.6. So that's a much bigger angle, so we'd expect that side to be much, much bigger. So, okay, in the San Gabriel Mountains in California. Hey, I've hiked the San Gabriel Mountains before. Lookout Station Running Deer, I don't know if that's real or not, I made that up, is 18 kilometers due west of Station Lazy Bear. Okay, so we have Running Deer, Running Deer, and Lazy Bear. Did I just go? Yeah, that'd be west. And that distance right there is 18 miles. Oh, kilometers, sorry. The bearing from Running Deer to fire directly south of Lazy Bear. Okay, so it's directly south of Lazy Bear, so it's down here somewhere. Directly south. See how that'd be directly south, 90-degree angle. The bearing is south, 38 degrees east. So that means if you look south, that's the starting direction, turn 38 degrees to the, whoops, I put that on the wrong end, maybe. Okay, erase that. Let's start over again. So Running Deer is here. Lookout Station Running Deer is 18 kilometers due west of Station Lazy Bear. Yeah, so Lazy Bear is over here. Now, the bearing from Running Deer, so if here's the fire down here. Yeah, the bearing from Running Deer to fire directly south of Lazy Bear. So here's my fire. So if you're looking south, you turn 38.4 degrees to the east, then he's looking at the fire. So that's 18, that's 38.4. That, of course, would be 90 degrees because it's directly south. So knowing that this is 38.4 and this is a 90-degree angle, that would mean this is 51, or yeah, 51. Whoops, I said 51. 51.6. Okay. So, to the nearest tenth of a kilometer, how far is the fire from Running Deer? From Lazy Bear. So we want to know this and this, don't we? Okay, so that's cool. Finally get to use something other than a tangent. So we'll call this x and y just to keep track of them. So to find y, we're going to use tangent again. So that'd be tangent of 51.6 is equal to opposite over adjacent. And so then we multiply 18 times tangent of 51.6. And we get 22.7. So 22.7 would be the distance from the Lazy Bear to the fire. And then for running deer, we would say we know the adjacent and we want the hypotenuse. So that'd be cosine. Cosine of 51.6. If we go back up here, right? Remember, cosine is adjacent and hypotenuse. Okay. So adjacent would be 18, hypotenuse would be x. So once again, we'd essentially switch the x and the cosine because you multiply by x and then divide by cosine. So you end up with x is equal to 18 over cosine 51.6. So then I go calculator, 18 divided by cosine of 51.6. And I get that x is 29 actually, 29.0. Okay. So I drew the picture off the camera so you can see it. So the balloon is flying 3,000 feet above the ocean, so there's the 3,000 feet. The angles of depression for each end of an island directly in front of the balloon are to be 75.8 and 15.6. So that means that this one here would be, it says angles of depression, which means we're going with this. The angle of depression is always between a horizontal line and a line of sight, right? So this right here would be 15.6, and the whole thing there would be 75.8. Okay? And again, really what we want to know is the angle of elevation from the island up to it, but because of alternating interior angles, we know that this little guy down here is 15.6 degrees, and this guy right here would be 75.8. So this one's a little kind of going to take a couple steps to get it done, because we want to know how long the island is, but that's not really part of a right triangle, but it is part of this side of the right triangle. So if we found the entire length of from here to here and subtracted off this one, that would leave us the length of the island. So we're going to do two problems and then subtract the results. Okay. So first of all, to get the long one, we'll call the long one capital T for total. Okay. So in this case, we know the opposite and want to know the adjacent. So that's going to be tangent again. So tangent of 15.6 degrees is going to be equal to 3,000 over the total, which means the total is going to be equal to 3,000 divided by tangent of 15.6 degrees. So let's see, 3,000 divided by tangent of 15.6, and I get T is approximately equal to 10,744.8. So then we're going to do the same idea, only to find the shorter side. We'll call it S for short side. So tangent of this time 75.8 degrees is equal to 3,000 divided by the short side, which means the short side is going to be equal to 3,000 divided by tangent of 75.8. And throw that in our calculator, 3,000 divided by tangent of 75.8. And we get 759.1. So finally, the length of the island length is going to be 10,744.8 minus 759.1. So minus 100,744.8. And we get approximately 9,985.7. Okay, this video is getting a little bit long, so I think I will stop the video. I'll do the rest of these and I'll post the solutions and then post the video. All right. Have a good weekend.